Well, hello everybody. Welcome back to another quarantine vlog. Today's another Kern day. Yeah! Yeah, I don't have a ton of time today, but I am going to be very productive. Feeling great. Let's dig in. Alright, so where we left off yesterday is machined the interface for a pallet so that this tombstone right there can bolt onto it. So we just got to flip that pallet over, hold it in a kind of weird way, dial it in, probe it in, and then machine the head pockets on the underside of the pallet. So let's change the pallet. So got the one pallet on there. Got a whole bunch of pallets lined up in here. This pallet changer is a game changer, literally. It just changes the way that I think about work. So, okay, so I need pallet 12. This guy is pallet 9, but I don't really care what it is necessarily. So I'm gonna go here. I've already warmed up the machine. I'm gonna go workpiece number. I'm gonna push over. I'm gonna push 12 and end. That's it. And then cycle start. Double check. Okay, it is pallet 12 that I want. And then cycle start. So I've already homed and warmed up the machine. I've homed the robot. Oh, it's so gentle. I love it. Notice the air that comes up out of there. Here we go. Oh yeah. Down one, yep. Gently grab that sucker. There are little gripper fingers, I think, pretty sure, that actually pinch the pallet. Oh yeah. And there's a rubber seal around the outside, that black underneath. And then the door closes and the C will orient forward. And then I know we're done. And I can open the door. All right. So now we're gonna grab that same pallet. I'm gonna open the pallet door. What did we say it was 9? So now I need 2 hands for this, but I'm gonna grab it, I'm gonna lift it upside down, and I'm gonna put it in that vise. So I just noticed something interesting as I lifted it up. You know, a decent amount of little coolant dripped out. Just because it's in there. So I'm curious how clean this is going to be after lots of production. I mean, it's very accessible. I can clean it. I can get in there. You know, we could spray it down and wipe it often. I'm curious how nasty it's going to get over time. So we'll got to watch that. Like, if this one drips, it's going to drip onto the one below it. And yeah, just things to think about. Maybe it's not a big deal, but something I noticed. I mean, it's been spotlessly clean this entire time, so I'm starting to see this. So it's not tight yet, but that's kind of what I'm thinking. I was going to mount it lower on the cap head screws, but I was kind of feeling weird about that because there's no way that they're all the same height, meaning the pallet is then going to be a little crooked. But then I realized I can do it on this shelf right here. Like you see on this side, there's a shelf with grippers. I can do it on this side, and I still have enough gripping room there. And then on this side of the pallet, there's a flat. So this flat area right there kind of orients the pallet, lets it, you know, make sure that we're in the right orientation, the right rotation, and then I need to probe it because there's no way I'm going to be able to guess perfectly center left to right. So we'll come in, maybe I'll pull out the pull stud, and then we'll probe this boss or something. Or actually, we could probe the outside of the pallet. Maybe I'll just do that. But this has got to be out of the way anyway, I think. Because well, I could probably clear it. I'm doing a countersink there, and there, and there, and there. I don't know, we'll see. I should probably remove that, but I might not have to. You can see how much it's sticking up. So you can see here in Infusion what we're doing. We're putting in this guy. For those, the pallets have this weird arch thing. Maybe it's got a purpose, I don't know yet. But they all have that in it, so one of the heads is going to be shorter and go right there. But yeah, the other three. So real quick, check this out. So here's my setup, right? According to the model, this chamfer will not allow the grippers to grip onto anything. You would never clamp like this because it's got nothing to bite into. But in real life, it actually works. Because if I hide that, and if I go measure, shift, click from the point to there, then I have down here, I have 0.154 roughly inches. So my chamfer across the angle is 0.154. However, when I look at my pallets, the actual pallets, and I quick and dirty do one of these, this is not accurate, but I've got about 70 thou. So the actual chamfer is about half what the computer thinks it is. So that's interesting. So I'm gonna actually look at this guy. This one has a big chamfer. I bet you that one's more like, that one's even bigger. So the model that I downloaded is more like that one. However, if all the ones I'm using have this smaller chamfer, I gotta update my model to match, just so that it's right. Because otherwise I will think that an operation like I'm trying to do right now ain't gonna work. And I can't be thinking that, because it do work. Much better. Look at that. Yeah, that's exactly what I've got in real life. That'll grip perfectly. So I've got some joints set up. I've been playing more with joints and trying to understand them better. So I've got some joints set up over here so that the model will track the flat side. You know, right there. And the vise is jointed together so that, you know, normally the vise is like this, but you just kind of fly it that way. And then I just move it to position here, and then if I want, I can lock it down or just not touch it. And then I still have to move it this way. So I've got a few joints in different axes right now. Here's a goofy little side thing for you. So I was just walking around the table here and I noticed one of my hairs on the table with the calipers literally right next to it. So instead of trying to pick up the hair, I just took the calipers and I picked it up. And then I figured I'd show you guys how thick a human hair is, or at least my hair. 3 thou, 2.5 if I squish it a little harder. So this is 3/1000ths of an inch, a hair, and that the tolerances that we're working in is a lot smaller than that. So if my part is off, depending on the part, some parts are fine, but if some parts are off by a hair, by 3 thou, it's scrap, it's way garbage. So that's that third digit. The first 0 and then the second 0 and then the third digit is a thou, or 3 thou in this case. And then the fourth digit, this caliper only goes in half a thou increments, that, you know, 5s and 0s. But that fourth digit is typically what I measure a lot of critical stuff to, as a 1, not as a 0 or 5. So this doesn't even get that accurate. Whereas a mic like this gives you an accurate fourth digit and then a 0 and a 5 fifth digit. So since we're doing it, use a Kern business card here. It's a little trick that Angelo taught me to clean the face of the calipers. Use a piece of paper, maybe not cardstock, but take this down to 0, good. Okay, where'd my hair go? So let's more accurately measure this hair. I think it's in there. See, this gives me 2.6. 2.5 when I ratchet the thimble. So there you go, 2.5 of an inch. So I've got a little baby dilemma here that I'm just trying to think through right now. Pocketing these holes is going to be no big deal because they're only 0.41 inches deep. That's fine. My flute length is 625. But this guy is 0.68 inches deep. The flutes on the tool that I have are not that long, so I'm actually going to have to put a different tool in the machine just to be able to pocket that little thing. So let's go see if I have a 3/8 flat that's that long. So deep in my collection of end mills that I don't use very often, so I've got this IMCO, whatever it is, but it's a 3/8 inch and a quarter inch flute length that I never use. And I have two of these, so this will be a perfect tool to have in the arsenal, in the machine. It's got a nice nice rake angle, sharp, brand new, sharp corners, long flute length for its size. Yeah, this will be a good tool to have in the machine. It's mounted up. So the first thing I'm doing is I'm modeling the tool in Fusion and adding it to my Kern cloud library so that I have kind of a standardized tool set. I noticed that this tool, Focus, has the coating going quite a bit down the shaft, so I got to figure out how far up do I want to clamp it. Do I want to go to there, or do I want to do a no-no and clamp onto the coating as well? Check this out. So if I measure the shank diameter, I get 3,748. Please focus. There we go. 3,748 on the bare carbide. On the coating, I get 3,749. So it's actually measuring, you know, they say the coating is almost nothing, but that's half a tenth per side. It is almost nothing, but it's something. And so theoretically you don't want to clamp on that. So I'm probably going to heed that warning and just clamp right up to there. It'll give me a little bit more reach for the future or whatever. It's a big enough tool that the extra stick out's not going to make a big deal. So I got to figure out how much stick out I need. I can get away with 1.7. All right. So in previous videos, these are the PG collets that we've been showing for a while now. A lot of you guys were mentioning that it's weird how I use the blue sticky tack to keep the tool at the right height where I want it. Well, they do come with little set screws on the bottom. I just don't typically like them. They don't always work for me. Even this one here, when threaded all the way in, I want the tool to stick out more than the set screw allows for. Apparently they make longer ones and shorter ones. I just don't have them. I have whatever came with the tools, and I've been pulling out most of them. Also, when I use a double-ended end mill, which I sometimes like to do, you don't want the double-ended side, the other good side, resting on the set screw. So I'm fine with my method for now. This is totally a two-handed operation, not one hand with the camera. Ta-da! 58. It's the magic number. Make sure the Rego fix is lined up. Pointing straight, not off to the side. Just for consistency. So you can see I can still fit quite a bit longer tool, like an inch longer, before maxing it out. Trying to get rid of that glare. Oh, there we go. Put my hand in front of the door. I just like seeing there it is, the red laser beam on that side. I think it's cool. Alright, so here we've got the Bloom touch probe mounted in the spindle, and I've got a touch probing routine that I think is going to go around the circle 4 times. 1, 2, 3, 4, automatically. I told it it's a roughly 6-inch diameter circle with a lot of clearances, and I'm going to slowly see what this is going to do. Touching the first side, lifting up. Good, I gave it a 3-inch clearance upwards. That should be good. Oh, it just missed. It was so much clearance that it timed out basically. It couldn't get close enough. Let's try it again. Okay, let's try it again. I started from the back position, now I'm going up, moving over to 9 o'clock. Perfect. Moving over to 6 o'clock. Beauty. And I don't have to have it go up so high, but I wanted to clear that post just in case. Beautiful. So that measured a circle radius of 2.91 inches, which converted to metric is 147.96 millimeters, and it's supposed to be a 148 millimeter pallet. So it's almost exactly a 148 millimeter pallet, which is sweet. All right, finally got my toolpaths ready. Jumping into complete here, we have the Kern model, which is so cool. I can hide the enclosure so I can see just what's going on here. Okay, everything looks good. I got my vise, I got my stock the right way. The flat being in the back. And I'm confirming my toolpaths to make sure that they clear that post in the middle. So you can see they go around in all ways, and complete simulates without any issues. Beauty. Working with Complete's been awesome. Like, the service guys, spent some time on the phone with them, got everything dialed to the way my vise goes on there, to the way the tool changes and lines up the taper properly like it should be. And yeah, I'm getting the workflow of this really, really dialed now. Here's a fun fact for you. The vise is not supported. I'm on the 9 o'clock position. There's nothing underneath it, right? So the pallet's actually vibrating, making a gross noise. It's actually not so bad now. It was really gross in the beginning. Makes sense, there's no support under it. And it's not held very well elsewhere. You know, it's not going anywhere, but it's jiggling, just ever so slightly. Making custom soft jaws to hold it properly would have been probably worth the investment, but this works. Oh, baby, baby, baby. We have 4 holes with, look at that beautiful shiny chamfer on the outside. Oh, I love it. I love it, love it, love it, love it. Look at that one. Therefore, this pallet's done. That means that guy and that guy can be put together. I was worried about this. You see right there? The grippy jaws kicked up a burr where they gripped into the material. I wondered if that would happen. I kind of figured it would. So that's okay. That's what my PFG stones are for. Oh, what's this, you ask? Remember the 2012 video of the integral? Well, this is the 3D printed version of it. And with the help of this will see the light of day eventually. Eventually. So, clean our stones off, and I need 2 hands to do this well, but I'll get that burr down, no problem. Yeah, it's working pretty good. Kinetic precision makes a good stone, you guys. Huh. That is exactly what these stones are for. When you have a flat surface and there's a scratch or a scuff or a burr or a nick or something, that's what these are for. It's working. Let's try the upside down taste test here. Ever so slight wiggle. I can just feel it moving on those pins, rotating, like barely. I hit it yesterday in the last video. I hit it a couple times trying to make those holes perfect, and I think I went just a few tenths oversized. But it's fine. Like, I'm totally over pickying this. For all intents and purposes, these two are probably never going to come apart. But if they do, and if I were having a surface where this was coming apart multiple times, I'd probably design it a little bit different anyway. But it was an excellent experiment for making super precision holes and pins. And it took a little bit of tweaking, which was neat to see. Skill, you know, gotta learn that skill. Okay, let's bolt them together, man. Figure out a torque spec for an M10 bolt so that I can use my torquey wrenchy, torque her down. In case you guys are wondering, I've been meaning to talk about this guy. So for years, you know, I've been married for 10 plus years, and always wore a gold wedding ring, and everybody's always like, ah, you can't wear a gold wedding ring, you can't wear a wedding ring in the machine shop, you're gonna get your hand sucked into a lathe or something. Very possible, it's true. I've sort of been breaking the rules doing that. But anyway, just a few months ago, my wife got me a silicone wedding ring, and it's rubber. Pretty sweet. And they're cheap, they're like, I don't know, 20 bucks or something. Usually they come in a 3-pack, but this one came by itself. So, theory is, if you're in a working, moving machine, especially a manual lathe, and you get your finger caught on the chuck, if this was a metal ring and it sucks you in, you could lose a finger, you could lose a hand, an arm, a life, etc. It's a real possibility. Whereas the theory with the silicone is it'll just rip, and you'll be like, oh, okay, that sucked, but $20 later you got a new one and you keep your fingers. So I really, really, really like it, not just from a safety standpoint. It's comfortable, it's lighter than it was before, and I just like it. It's cool. I just remembered something. Trying to bolt these in. The bolts that I have are all 5mm too long because I was planning on using M8, which I bought a box of, but then I screwed up the threads a couple videos ago, so I had to go up to M10. The only M10s that I have are all 5mm too long. So let's jump over to a machine that we haven't been on in this quarantine series yet. The Nakamura. I've had this guy for 3.5 years. Yeah. Currently it's set up to make our pen clips, the Saga pen clips, which is the clip right there. But it's pretty fast to set it up, turn it on, throw one collet in, and then the bolts can go through the back, stick out the front. I can quickly touch off the face and just cut off 5mm. Shouldn't take too long. I thought about going at the grinder or bandsaw or something, but I'm like, let's use technology. I'm gonna use this as a manual lathe. If I had a manual lathe, I would be doing that. But we don't, so we have an expensive CNC machine that we're gonna use manually. So let's give you a look inside the Nakamura AS200 LMYS. Yeah. So this is a turret lathe, much different than the Swiss lathe right there. The turret rotates around and presents all kinds of different tools. Like we got some drill bits down there, we got a threading tool, OD and ID, we got a live tool here. This is a spinning end mill type tool. Live tool sticking radially, this is axially. Back in the back you got 2 boring bars sticking off each side. All kinds of fun stuff. We got a main collet, a sub collet. So it makes your part here, blah, 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 and then the sub collet comes in, grabs it, cuts it off, and then brings it back here and lets it finish work on this side. Really sweet setup. So anyway, I'm just gonna hit this pedal. That opens up the collet. I'm gonna pull out this bar of material, give it a little shake. Put it right there for now. I'm gonna loosen this screw, pull out this collet, put the other collet back in, and we're ready to rock. Time lapse. It's neat. I haven't used this machine in quite a long time, and I've been so into the Swiss lately and into the Kern and doing Mori stuff too that, I mean, each machine is different. Each machine has its own little quirks and features, and this one's got an M471 that you got to type in before you can move the Y-axis. It's come back to me, but it's been months and months since I've personally used this machine. Angelo's been running it by himself for a long time, which is great. But yeah, it's like it's like riding a bike. You get back into it, and you're like, oh yeah, I remember that now. Okay, yeah. So let's take a closer look. So I've jogged the axis down, I'm spinning it manually. I've got my double stack of tools there with one of them right up to the part. I've zeroed the Z axis to be the new face of that part, so I just got to go whatever 5mm is in inches inwards. I think it's 0.196. Anyway, spindle forward, this is my RPM. And then I'm just X-axis, just jogging it, making my cut. Do this manually. Maybe I can set up the camera here. Well, that's not so bad. There's a glare. All right, that's the best you're gonna get. There we go. There we go, okay. Manual focus, stay there. That's good. Okay. See the that brass coolant line right at the very top top left of the screen. I gotta be careful. I don't crash that into the spindle.
So I'm just moving over a little bit in Z, down in X. Here we go, cutting some chips off. Back up. Over a couple times in Z. Down in X. Nothing too complicated. So you can see my bolt is almost gone. I had just enough stick out. It's perfect. Oh, that little boo-boo. I remember that little boo-boo. That was not a fun day. Still works great though. So the only downside to having the screw go in the back side of the collet is now I gotta pull the collet out for every screw. But no big deal. Come on. Ta-da! Just gonna run to the grinder real quick, put a quick chamfer on it, 45 degree around the outside. And then we're good to go. So like with anything, there's many different ways to accomplish a certain task. Using the Nakamura to shorten these screws, probably not the easiest or fastest way. I mean, shoving them into the grinder would have shortened them after a little bit of time, although that grinder's really underpowered. But I could have walked over to Eric's shop and I could have, like, you know, shoved it into a big 2x72 grinder with a 60 grit belt or something. Could have done that. Didn't want to. Wanted to use the lathe, my baby. I haven't used that thing in a long time, so that was fun. They look really good. They look awesome with the chamfer. And let's put this thing together. Oh, still a manual focus. That's better. Hope that last scene was in focus. Right, you may be wondering why there's one black one and 3 silver ones. Because of the design of this, that oval pocket that I have right here, I need one shorter screw to go down. I'm gonna blow these off after grinding them, actually. All right, that one goes in there. Nice. 2, 3, 4. Little bit of a burr from that grinding up. Right. Sweet. Now I can torque them down and we're good to go. All right, guys, that does it for me tonight. I'm taking a few days off, spend time with the fam. Hope you guys are doing well. And I'll see you sometime soon when I come back. Later.